back in today's online class. Today we'll talk about chapter combustion. Okay. Combustion is generally called the burning of any substance which give us light and heat. It's called combustion. It is a general term where I'm saying that combustion is also called burning. But as far as the science is concerned, combustion is called a chemical process. Okay, where a combustible material burns with the release of heat and light energy. Okay. Uh, in science, we say that combustible materials burn with the release of heat and light energy. Okay, in presence of oxygen or air, and the substances which burn uh, is called combustible material. Okay, they are also called fuel, like petrol, diesel, coal. Uh, these are the examples of combustible material as well as fuel. Okay, so we can say combustible is a chemical process in which substance burn in air or oxygen with the release of heat and light energy. It's called combustion. The substance that undergo combustion is called combustible substance or fuel. A fuel may be solid, liquid, or gaseous. Means fuel is available in all three forms, that is solid, liquid, and gaseous fuel. See, solid fuels are coal, wood. Liquid fuels are petrol, diesel, kerosene. Gaseous fuels are LPG, CNG, etc. Okay. Now see here, some materials are given, and we have to categorize them in combustible or non-combustible material. Mastic is categorized under the category of combustible material. Paper, combustible. Cloth, combustible. Rubber, combustible. Iron nail, non-combustible. Glass rod, non-combustible. Straw, combustible. Okay, these are the substances which are either combustible or non-combustible. Now let us talk about the conditions required for combustion. See, as we have discussed that combustion is a chemical process, so it has some required conditions. Okay, without this condition, combustion will not take place. See, what are those? What are the conditions of combustion? See, one activity is given here just to understand about the first condition. The first condition is that for combustion, the continuous supply of air or oxygen is must. Without that, there will be no combustion. See how it is so. To show that, we've taken one burning candle and we fix it on a table. In this second picture, we have seen that one chimney is put around the candle, and in third one, it is covered with a uh, flip or with a wooden piece of a wooden block. So what we find in picture 1, candle is burning properly without any disturbance. But in picture 2, the candle is flickering, but the flame flickers, okay, and becomes sooty sometimes, means give smoke. Okay? And in third picture, we see the flame goes off, means flame uh, put off. Okay, flame will not continue, means candle will put off. So, in first case is burning properly because there is a proper supply of air or oxygen. In second case, it is flickering, means producing a lot of soot, smoke. It means there is less supply of air due to this chimney. And in third case, it is covered with an wooden block, means supply of air is cut off, and now uh, the candle is put out. Means now there is no fire. So this activity proves that for combustion, air is necessary condition. Means without air, there will be no combustion. Air is required for combustion. Okay, or we can also say oxygen because uh, uh, from air only oxygen is used for combustion because oxygen is supporter of combustion and rest are not. See, one thing is given here in do you know? In pure oxygen, a substance burns 5 times faster than in air. Pure substance, sorry, in pure oxygen, a substance burns 5 times faster. It means that as only oxygen is utilized for burning, so if we will take air, then we get only 1/5 part of air as oxygen because we know that there is 20% oxygen present in air. So whatever the amount of air will be taken, from that only almost 1/5 part is oxygen. But if we take pure oxygen, then the fire will be 5 times faster than that of the fire with air. Okay. It is due to the presence of oxygen. Now the second activity for second condition. Second condition is that to burn any substance, we need to heat that substance up to its ignition temperature or above its ignition temperature. To burn any substance, we need to heat that substance up to its ignition temperature or to above its ignition temperature. See, one activity is shown here. We've taken two paper cup. One is filled with water and other is having no water. And we have put the both on a flame. We found that the cup which has no water, it burns. It is a it is that mm, paper cup that is burning. But here, this one has water, so it will not burn because whatever the heat is supplied, that is being utilized in heating water and then boiling water. Means that heat is not able to meet the ignition temperature of this wooden this paper cup due to presence of water. Means वाटर के कारण इस पेपर का टेम्परेचर बढ़ नहीं पा रहा है, वो हीट कहाँ यूज हो रहा है, पानी को बॉईल करने में. ठीक है, इसलिए यहाँ इसमें आग नहीं पकड़ रही है और इस पेपर में आग पकड़ रही है. तो दिस इज व्हाट this shows that to burn any substance a particular temperature is required. It should be heated up to that temperature and this is called ignition temperature. Means substance should be heated up to that temperature that is called ignition temperature, then the fire will take place. Means second condition is substance should be heated up to ignition temperature for burning. Okay. Now the third condition. Third condition is the availability of combustible substance. Okay. So there must be three conditions. One is uh, availability of combustible substance. Other is continuous supply of air or oxygen. And third one is the temperature of substance should be up to its ignition temperature or about kindling temperature. So we have discussed that why, what is kindling temperature and what is ignition temperature. We have discussed that because the heat that is required to burn any substance is called its ignition temperature. See, ignition temperature of phosphorus is 35 degrees centigrade. Phosphorus burns at 35 degrees centigrade. Okay, phosphorus uh, has three forms. The white phosphorus burn at 35 degree means if it is kept in room in summer season it will burn automatically in open air because it's burned only at means its ignition temperature is very less, that is 35 degrees centigrade, so it will burn automatically. Okay. A matchstick is lighted when we strike it on rough surface. So that striking of matchstick on rough surface produce that much heat which is required for the combustion of the chemical that is put on the tip of the candle flame. Okay. So that much heat is given, that is equivalent to its ignition temperature on striking the matchstick on the rough surface. So here are some examples we have discussed about the ignition temperature. Okay. Now we'll talk. See once again have a quick review of the 3 points, which are there must be a combustible material, there must be uh, there must be a continuous supply of air or oxygen, and temperature should be above the ignition temperature. Okay, then only the combustion will take place. Now we will talk about the type of combustion, that is slow combustion, rapid combustion, mm, spontaneous combustion, and explosive combustion. Combustion is of four types. First one is slow combustion. When a combustible material burn at a slow or moderate rate, its combustion is called slow combustion. Means here combustion takes place at a moderate or slow rate. Okay. For example, burning of cow dung cake at home, as cooking fuel, burning of wood, they are examples of slow combustion. Now question arises, why there is slow combustion? Why wood burn with slow rate or moderate rate? Reason is that here uh, the supply of oxygen or air to these materials are not proper. The supply of oxygen or air to this material is not proper, so the combustion is at slow rate because the fuel is in solid form and oxygen or air doesn't mix with the fuel properly, so there is slow combustion. Okay. Now uh, about rapid combustion. When a substance burn at fast rate, its combustion is called rapid combustion. For example, gaseous fuel generally undergo rapid combustion. Uh, how? Because here in gaseous fuel, the air or oxygen mix properly, and hence the combustion takes place completely. Means in a gaseous fuel, the combustion is proper or there is complete combustion, so it is called rapid combustion. Means here the combustion takes place at fast rate because here the air or oxygen mixes with the fuel properly because fuel are in the gaseous form. Now we'll see the next one is that is a spontaneous combustion. Uh, when a combustible substance catch fire on its own at room temperature is called a spontaneous combustion. Okay. Uh, See, uh, as I have discussed previously about the white phosphorus, sodium metal, potassium metal, they burn automatically at room temperature because uh, their temperature of ignition is very very low. That is near about room or less than room temperature. So they burn automatically. So we can say a substance or a fuel which burn, which temperature of ignition is very very low. They are called, and their combustion is called a spontaneous combustion. For example, combustion of sodium, potassium, white phosphorus, etc. Uh, See some substances which you see around you, that is tanker of diesel tanker, petrol tanker, LPG cylinder tankers. It is written over there that inflammable substances. It is written on those vehicles inflammable substances. It means what? These substances are flammable, means they can catch fire easily, means they have a low ignition temperature. They catch fire easily. Okay, so it is advisable that keep away from those vehicles or keep away the firing object with those vehicles. Okay, because it is very dangerous. Now the last one is explosive combustion. In this type of combustion, a mixture of combustible substance and air burns completely in a very short span of time in a closed space. When combustion takes place in a closed space and in very short span of time, it is called explosive combustion. Here the whole material catch fire at once. It will burn within a within few seconds. Okay, and it release a lot of heat and um, sound because uh, this type of combustion is out of control. It is uncontrollable. It is uncontrollable. Means we cannot control it. This type of fire is out of our control. So these are called explosive combustion. Okay. For example, when a cracker is ignited, a sudden and rapid reaction takes place. When we ignite any cracker, a sudden and rapid reaction takes place. We produce a lot of heat and light, sound, energy. So it is called explosive combustion. Okay. Since it produces a lot of sound at once, so it is also called explosion. So the combustion takes place in bomb is example of explosions. So these are the four types of combustion, and for all these four, there are some basic reasons. Okay, so uh, we have discussed about the first one, slow combustion, due to the less or insufficient supply of air. In second one, rapid combustion due to the proper supply and due to the type of fuel, that is gaseous fuel. Okay. In third one, that is the spontaneous combustion. There is due to the low ignition temperature. Here, fire takes place automatically. So it is called a spontaneous combustion. And the last one is explosive. Here, uh, the whole fuel burn with uh, burn at once within very short span of time. That is only in few seconds it burns. Okay, and it is out of control. It produces a lot of energy in the form of heat and sound too. It is called explosive combustion. These are the types of combustion, and it is all for today's class. In next class, we'll talk about the fire control and about the fuel. Okay?